In the last video, we talked a little bit about how functions work and how to use the vertical line test. So I pulled up some examples here to give you an example. And there's a few things that I want to look at here. First, I want to look at domain and range of each of these proposed functions. And I want to look at, is it an actual function? And is it continuous, which we haven't really talked about yet. But I'm just going to touch on it. So when you're looking at a function and you're looking at the graph, we talk about how a vertical line, if I draw one anywhere on here, should I make that a little darker? Let's make it a little darker. Anywhere I put this vertical line should only cross at one time. So if I come over here, you can see that I'm crossing the graph a few times, right? Over here's one, and here's one. So immediately I know that this guy is not a function. I hope you can appreciate that. The vertical line test is very important. We don't need to know the domain and range if it's not a function. And this here is a secret version of that because look, we can put a vertical line right here, and it's going to get all kinds of points here. So this is not a function. That is not a function. And I want to look at this guy next. This passes the vertical line test. There's no point in which a vertical line touches it twice. So we can go to the next step and say, okay, what's the domain and range? Well, the domain I think of as just simply the x values, and the range I think of as the y values. So if I'm on the graph here, well, here's the far left and here's the far right side. Well, what's this x value? That's -2. What's this x value? +2. So we'd say the domain is x such that x is between -2 and 2. And then you want to check and see if it includes the border there. If it's dark like that, then that means it's less than or equal to and greater than or equal to that. Then for the range, well, those are y values. What are the range y values? Here's the highest point, height, that's 2, and the lowest point here is at -1. So we'd say y is between -1 and 2. And we'll say it includes it. It can't be totally certain, but it sure looks like it. So this would be the domain and range. Is it a function? Yes. Is it continuous? Well, was there anywhere on here where it breaks apart? Was there anywhere on here where if I approached it from the left and I approached it from the right that you would come to a different conclusion? No. So this is a continuous function. Okay. This one, already done with it, right? These are fast examples. Let's come to the last guy here. And of course, you see right here, we are discontinuous. If I am traveling from left to right, I would get here, but from right to left, I would get here. That is discontinuous. That's the term you want for that. It's still a valid function, maybe. We have to check vertical line test. Do you see any vertical lines here that wouldn't be good? Be careful, because if I look right here, this is an open hole, which means it doesn't exist there. And this is a closed hole, which means it does exist there. Which means this is very likely a function. It's a piecewise function like we talked about in the last video. So it's not continuous, but it is a function. Then now let's look at its domain and range. Well, the domain, I'll remove the old guy just to keep it out of the way. The domain is all the x's such that what? Well, what's the far left? That's -1, 2, -3. And it comes over here, which is to the +2. So x is between -3 and 2. And does it include them? It does on one side and the other side, so they're less than or equal to. And then the range, the y values, well, what's the lowest? That's down here. That's at -3. What's the highest? That's up here. That's at +3. And it includes them both. So it is going to be less than or equal to. I hope this is a refresher for you because you're walking into calculus. You should have a pretty good idea of this. But I just want to give you a quick example problem set for how you might look at functions on paper before we move on.